going properly. I'm never 100% sure with the stream, so yeah, hopefully it's working properly. I'll just check it out. Yeah, it seems to have started. Good. Right, so plan today. It's the night before the Edexcel IGCSE paper. It's tomorrow, Wednesday. So I'm going to go through the rest of this paper. We're up to question 17, but it goes up to about question 25. Hello, hello. So yes, carrying on. Going to finish off this paper. There's about 8 questions left, I think, but they do look quite difficult, some of the ones at the end. And typically, if they do go on to, past question 22, 23, they are going to be quite difficult. So, yes, that's to be expected, to be honest. Hopefully you can see me okay. Is this playing properly? I'm not sure. Yes, it is. Right. Okay, right, I'll make a start. I'm going to kind of just go through it as quickly as I can, but try and explain everything at the same time, and then I can talk through maybe some topics or put on the screen quickly some topics from my video that I shared that was highlighting some of the topics that I think are likely to come up on the paper too. If you haven't watched it already, it's worth checking out, I think, because I talk through in a little bit more detail where you might expect to see those questions, how difficult they might expect to be, where you could pick up some marks even on those more difficult ones, and which ones I think are the most likely to come up. Right, so without further ado, let's get started with this. And yeah, in the chat, you're right to put in there quickly. You're already ahead of me. You're already doing the question, which is great. Right, got the pen working. Let's get going. So exactly like you put in the chat there. I'm not sure exactly how to pronounce your names. I'm just going to say R, but yes, you're right by noticing that this is x plus 6 all squared times by 3x minus 2. Hello, hello. I assume that's not the real Molly May, because I say real Molly May, you're obviously a real Molly May, but not the Molly May on that everyone knows from Love Island. Anyway, I'm digressing. Right, let's do this. So x plus 6 times by x plus 6 times by 3x minus 2. Okay, so x times x, 6 times 6, and then 6 times x, 6 times x. So I'm going to get x squared plus 6x plus 6x. Thank you, appreciate that. So 12x, because you've got 6x twice. Okay, we've got this 6x here and this 6x here. This, I don't know, well, I do know why, but I call this like eyebrows here, mouth, and a nose. Just my way of remembering it. Other people draw it slightly differently and call it like a claw method. Either way is fine. Now I've kind of skipped a step here because I've added the 6x here and the 6x together straight away to give me 12x. Right, that is then going to be multiplied by 3x minus 2. Now, the easy way to do this is just to multiply everything by 3x and then everything by minus 2. Okay, so I'm going to get 3x cubed, x squared times 3x, plus 36x squared plus 36 times by 3, I believe is 108. I'm just going to double check. Yeah, 108x. I've just turned the computer on and every pop-up in the world is coming up. All the calling, antivirus, all sorts. Right, minus 2 times 12x is minus 24x, and then minus 2 times 36 is minus 72. Yesterday was, yeah, that's how, because yesterday was the same paper exactly. So that's why I've started halfway. So if you want to check out the first half, that if you go onto my channel, go under live, it's that stream from yesterday. So yeah, plan is finish this paper off and then talk about some of the topics I think are most likely to come up on tomorrow's paper. So at the moment, I'm just doing here the x squared. I'm combining the like terms essentially. So 108 minus 24 is 84x. Okay, and then I've got the minus 72. Okay, so that should be my answer there. I'm just going to double check I've done that right. 36 minus 2, 108 minus 24, yep, is 84, and then minus 72. Okay, so that should be our answer there, yep. Okay, right. Next bit, make E the subject of this. So for this one, well, I'm just checking the comments as well. Yeah, well done in the comments for getting that right. Super. This question, we need to get E as the subject. You'll notice we've got E twice here. What this tells me is I'm going to need to, at some point, factorise the E out and then divide by that bracket. Or at least I'm pretty sure that's how this question is going to work, because that's almost always how these work. So square both sides. I'm going to zoom this in slightly. Part of that is for you, but also I've got more room to write. So w squared equals E plus G over EF minus D. Okay, multiply up by the denominator, so w squared EF minus D is equal to E plus G. Expand the bracket, so it doesn't really matter where we put the w squared here. So E squared, not E squared, excuse me, it's w squared. So EF w squared minus D w squared equals E plus G. We need to get everything with E in it on one side, everything else on the other side. So I'm going to add dw squared to both sides. Scroll that down. Equals E plus G plus D w squared. We're going to subtract E from both sides. EF w squared minus E equals G plus D w squared. Factorise the E out. F w squared minus 1 equals G plus D w squared, and then divide by this bracket. So G plus dw squared all divided by F w squared minus 1. Okay, and that is our answer. Okay. Right. Well done. Yeah. I mean, impressive as well that you were able to type that as well so quickly. So why are there two w squareds? Because at this point here, we've expanded, so the w squared is multiplied by the EF, and it's multiplied by D. Okay? So, yeah, you end up with w squared in two places. Okay. Right, moving on to the next question. So, graphs 1. This is a case really of, well, obviously understanding the graphs, but practice, because this is a fairly typical kind of question that comes up. It's not unusual to see this type of question. What we need to understand is obviously what these graphs represent, but also what these equations look like. So sine x is a standard graph that we would be expected to know, the same as cos x, the same as tan x, okay? So that would be something I'd put on a flashcard, especially if it's something you don't know already, and just make sure you know those. And you can learn those pretty quickly on a flashcard, so you can do that tonight pretty straightforwardly. The other ones, cubic here, this one's a reciprocal, okay? So now we can do a couple of things with these to, well, specifically this last one to see what it's going to look like. We can factorise this. So you can see here both terms have got x in. Sine of 0 doesn't equal 1. That would be cos of 0, yes. Cos of 0. So sine of 0 is 0. And cos is the one which starts. Cos basically starts up here, it goes down to -1, comes back up, and finishes up there. Okay, so that's whole 0 to 360. Okay, right. Just get rid of that bit. I can use that to do my other sketch in a minute. So factorising this, we can take an x out of both terms here. So we get x and then 4x squared minus 5. Now this doesn't tell us loads apart from, obviously this is positive, which means the cubic is starting bottom left and finishing top right. And also this bit, the fact we can factorise an x out tells us that it has to go through the x-axis at 0. It tells us that one of the roots is 0. Okay, so if I go up, and look at my diagram here, this looks like it. Okay, starts bottom left, finishes top right, it goes through at 0, 0. None of these other ones, apart from this one, but this clearly isn't a cubic, does that. Okay, so that last one has to be A, and to be honest, you could work that out without doing that factorising bit there. So yeah, that's fine, that's done. The next one is minus 3 over x. Now, if you had a normal reciprocal, by normal what I mean is a over x or 1 over x, that would be like graph B, okay? But because we've got the minus here, what that does is it makes everything that is positive negative. So this would go from here down to here, and this would go from here up to here. So this is going to be graph F, okay? So that negative in front is important. Now it doesn't actually matter what number is at the top here, okay? Because these are sketches, it's not going to change the shape. All it's going to do with the reciprocal is it's going to be further away. So if you had them drawn on the same grid, and I had, let's say this is minus 3 over x. If I wanted to do minus 4 over x, it would look something like, so if I did 4 over 1, then that would be bigger than 3 over 1. So what you end up with is something which looks something like that. Now, basically the curve is just further out. Now, that doesn't make a difference when we've got a sketch, like I say, because you can't tell, if you've got nothing to compare it to, what that curve is like. So the number on top for this doesn't matter for reciprocal graphs. And then sine x, as I said earlier, sine x starts at 0, 0, goes up, goes back down, and then goes up again. Not the best drawing, my hand slipped, but that's 360. Oh, sorry, I need to move this along slightly. So that's 360, this is 90, sorry, 180, excuse me. 90 is the bit across. This is 180, this apex here is 90 and it goes up to 1, this goes down to minus 1, and this is 270. Okay, so half, 3/4, 1/4. Okay. So sine x, actually doing the question now, sine x is C. Okay. Right. Okay, going down onto the next question then. This is a completing the square question. Fairly straightforward, this question, as long as you have seen something like this before and you've practiced it enough. So, what is this subject called? So the one above, well, I mean, it's a difficult one. It would be, in terms of subject specifically, it would be types of graph, or it could come under like sketching graphs. It's basically having a knowledge of what certain types of graphs are. So if I have a quick look on something, I have a quick look on a website called Maths Genie, which I do recommend, and I can find you what that topic is down as on there. Right. So just having a look, they've got an IGCSE section as well, which is helpful. We have a quick search. So there's drawing graphs, that kind of wouldn't be it really. I mean, to be fair, there's no section specifically on that, but there are things that would cover what those graphs look like. So things like trigonometric and exponential graphs. So just sketching those, learning what those look like. There is cubic and reciprocal graphs and drawing those. And again, practicing that will help you recognize what they look like. Quadratic graphs. And then obviously you've got linear graphs or straight line graphs as well. So just practicing any of those that you're not as confident with. Or to be honest, with a question like that, it would be quite easy to just open loads of papers and scroll through until you see a question like that and have a practice. I actually didn't get a chance to see your Desmos graph yesterday, so if you can share it again, that'd be very helpful, because I didn't realise when I closed the live stream it disappeared, so I'll make sure to click it in the chat this time before it disappears. Right, this question. This is completing the square. It's harder than maybe some other ones because we've got this number here in front of the x squared. And so what we need to do is factorise this number out of the first two terms, at least. I would normally go with the first two, You can do all three if you want, but you don't have to. Okay. Right, so we get that, and do you know what? I'm actually going to do square brackets here. It will make sense in a second if you're not sure why already. So take the 3 out of these first 2 terms here, factorise those, but leave the x in there. And then what we're going to do is we are going to complete the square on the inside of those square brackets. So to do that, what you do is you do a bracket, you do x, you halve this number. So -2 goes to -1 squared. Okay, and then you subtract the number in the bracket squared. So we're going to subtract 1. Okay, then you've still got the add 5. So we've just changed the bit inside of the square brackets. Okay. Now, if we expand this, we'll get x squared minus 2x. Okay, because this bracket squared will give us x squared minus 2x plus 1, and then we take the 1 away. So these things are equal here. To get this number, you halve the number in front of the x. To get this number, you take away, always take away, this number squared. Okay, now what we're going to do is re-expand the square bracket. So 3 times the squared bracket and 3 times the -1. I'm saying squared bracket, not perhaps appreciating there is a squared bracket and a bracket squared. So I apologise. What I meant is this. So 3 times x minus 1 squared, 3 times -1 is -3, and then we've got to add 5. So that gives us 3 lots of x minus 1 all squared. -3 add 5 is add 2. Okay, and that's it there. Right. Moving on then to the next one. Probability question. I did say yesterday, this is probably most people's well, not one of most people's favourite topics, we'll put it that way. Probability. Just because there can be so many different layouts, types of questions, and so, not so many, but some different ways to approach them. So this one, 12 counters in a bag, 3 of the counters are red, 9 of the counters are green. So automatically I'm thinking tree diagram here, although it might not be. Or might not be the best way to do it. Let's see. Amaya, Jack, and Ella each take at random 1 counter from the bag. Right, I'm starting to change from my idea of tree diagram. Work out the probability that at least 1 red counter is still in the bag. Right. So, if 1 red counter is left in the bag, then the scenario we can't have is that all 3 of them take a red counter. Exactly, yes, that's right in the chat. So, probability. Let's work out the probability of red, 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 first of all. So that would be 3 out of 12 times by, now they've taken 1 out, so it's going to be 2 out of 11 times by 1 out of 10. Okay, so that's going to give me 6 out of something. It's 1 over 2 to 0. Now, if we just do 1, subtract that, I can't think of a reason at the moment that's not going to give us the answer. So at the moment, I'm getting 219 over 220, which if I simplify the answer that you got in the chat, you got 1 over 220 like me, and then subtracting it, because that is the probability of getting all 3 reds. That's the only thing we can't have, because we could have no reds, we could have 1 red, we could have 2 reds. Okay, so that, I don't see any reason why that wouldn't work. Okay, so that should be the answer to that question. Yeah, perfect. Okay. No, I have no idea who that person is. Unfortunately, or fortunately, I don't know. No, I don't know who they are. There may be some very distant relation, but yeah, I don't know. Right. Let me have a look. I can see there's 12 people, so I don't know why. Yeah, maybe Maybe you're seeing something else. Anyway, it doesn't really matter. If it's helping one person, like I said yesterday, like I always say, that's the main thing. Right, here, simultaneous equations. This is a bit harder because we've got the squared parts here. Now, typically what that means is we're going to substitute in rather than adding or subtracting. How do you know when to add or times? Good question. It's not really applicable so much to this one, but let me give you a quick example. If we had 2x plus 3y is equal to, I don't know, 7. I'm just making this up, so this probably won't be nice numbers in terms of solutions. If we then had something like, if I had 5x plus 3y equals 10, okay, then we could, in this case, because we've got plus 3y for both the y terms, we would subtract. Okay, same sign, so same sign beforehand, subtract. Now if I give you another example, just to be clear with this, so if we had minus 3y, okay, these numbers in front of our y's are the same, but the signs are different, so we're going to add both equations. Okay, now I'll change it again slightly. If I went from that to being, let's say 5, and this to being 2, again, these probably won't be nice answers. Then here, x's are the same. They're both the same sign. They're both positive, so you'd subtract the equations. Now, from that, if I then change one of them to a minus 2x, signs are different. This is a positive 2, this is a minus 2. So you add the equations together, okay? Right, now the scenario where you would multiply, let's say this is, I'm going to go with 4, okay? You can see that this is 2, this is 4, okay? So we could make them the same by multiplying this equation by 2. Okay, so multiply it all by 2. They're then going to be the same signs. They're both going to be positive 4s. So you're going to subtract the equations. Same sign, subtract. Now from there, if I make this into, let's say, 5, at this point you could either look at the x coefficients or the y coefficients. Okay, so it doesn't matter, but at this point I'm going to have to multiply both equations by something. If you do it on an A-level calc and not showing working, would I still get the mark? Depends on the wording of the question. Some questions say your solution must not rely on calculator technology, in which case you may not have to show your working for that because it's saying the word rely. I think it's always best to show it and just check with the calculator just to be safe. There's a slightly different variation of that wording where it says along the lines of basically calculator technology can't be used. Okay, right. There's no need to be rude. Enough waffling. No need for that. If you don't want to watch, don't watch. You asked me a question, I tried to explain it. Right, moving on. I say moving on, I need to do this question first. Right. So this one, we need to substitute because we've got x squared here. Okay, this is a quadratic question. So, what I'm going to do is substitute in, because I'm told it x is 3y minus 1. I'm going to replace the x here with 3y minus 1. Okay, so I'm going to get 2 lots of 3y minus 1 squared plus 3y squared equals 11. Okay. Second. Right. Okay, sorry, carrying on. So from there, I'm going to expand this bracket. 2 lots of 3y minus 1 times by 3y minus 1 plus 3y squared equals 11. Okay, so then we're going to get 2 lots of 3y times 3y is 9y squared. So I'm doing that method of eyebrows, mouth and a nose, or you can do a claw method. So 9y squared, and then I'm going to get minus 3y, so that's minus 6y, and then minus 1 times minus 1 is plus 1. plus 3y squared equals 11. So from there, multiply everything by 2. I'm going to get 18y squared minus 12y plus 2 plus 3y squared equals 11. Now from there, I'm going to collect my y squared terms. So I'm going to get 21y squared minus 12y plus 2 equals 11. I'm going to subtract 11 from both sides of this equation. Thank you, appreciate that. I'm going to get 21y squared minus 12y. 2 minus 11 is minus 9 equals 0. I'm then going to divide everything here by 3, and to be honest, I thought, looking at this at the start, it's 21y squared, and I didn't really love that, to be honest with you. I want to make that a bit nicer. So I'm going to divide everything by 3, and I hoped that I would be able to divide everything by some number, because like I say, I don't like 21y squared. It doesn't strike me as something that I'm going to be able to factorise quite easily, and ideally I want to be able to factorise it. I don't think even doing that I'm going to be able to, because I'm going to get 7y squared minus 4y minus 3. Now you could do a bit of trial and error here and try, yes, we can do a vector question, yeah. We can try and factorise it, but to be honest, that would be a bit of a waste of time. At this point, I don't want to do trial and error. It's going to take too much time. Quadratic formula, okay? So if you've forgotten, quadratic formula, I'll just do it at the side here. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now don't worry, this is on the formula sheet. Y divide by 3, because they're all multiples of 3. Now you don't have to do that. You don't have to do that. If you don't spot it, don't worry. You can just plug it all into the quadratic formula straight away. Sometimes it makes it easier to factorise and you can just see it and do it, but sometimes it won't, like this. Okay. Because it's 2x squared, I don't think you doubled. Let me have a look. No, so you square it first and then you times it by 2. Okay, so you follow the rules of BIDMaths, BODMaths, okay? Indices first, so brackets, indices, and then multiplication, division, addition, subtraction. So square it and then times it all by 2. Now, to be honest, if I do make a mistake or you make a mistake with this type of question, what you do at the end is you substitute them back in and see that they work in both equations. Okay, and then you know, and then you can move on and forget about it for the rest of your life. Right, quadratic formula, let's do this. So y equals minus b. Now b is 4, so that's going to be minus 4 plus or minus the square root of minus 4 in brackets. Key tip here. When you were doing quadratic formula, and any of the numbers are negative, but particularly this b number, put it in brackets. If you don't, your calculator will get it wrong. Okay, it will square the 4 and then make the answer negative, which is not what we want. So b squared minus 4 times a, which is 7, times c, which is minus 3. And we're going to divide all of that by 2 times 7. Okay, that's going to give us 2 values for y, which is perfect, that's what we want. And then we're going to get our values for x. So let me just smash all that into the calculator. Square root brackets minus 4 squared minus 4 times 7 times minus 3 times divided by 2 times 7, which is 1, which is actually a really nice number. It makes me confident that I've done that right. Okay, and then we get minus 3 over 7, which, looking at this number here, the 7y squared, is what I would not appreciate, is what I would expect. Okay, is it also okay to put it into a calculator under the polynomial function? Now, I think to be safe, I would write down the quadratic formula like I've done. You can check it on there, so you can definitely check it on there, and I think that's worth doing to make sure you have done the quadratic formula correctly, but they may want to see your method, okay? So write down the quadratic formula, okay? Put that in, and you can check it if you're not confident on the polynomial bit. But they may want to see a method with this. Now, it does say show clear algebraic working here. So I think there will be a method mark, and if you don't put that, you may not get your final marks, your answer marks, okay? So yeah, do show you're working out. Check it with the polynomial function. But good suggestion about, well, and good mentioning of that, because that's an important thing that you can do on the, well, the A-level calculator, some people might call them. But here, like this Casio calculator, okay? Sorry, said okay again. I'll do my best not to. Right. So next thing is finding out the x that we've got. So x is equal to 3y minus 1. We're going to do 3 times y minus 1. So x is equal to 3 minus 1 is 2. Okay, so that's one solution. Over here, x is 3 times minus 3 over 7 minus 1. Yes, you do, Molly. You do get the formula for the quadratic. Sorry, you do get the quadratic formula. Yes. Minus 16 over 7. Okay, so there's our answers there. And one tip as well, just write them together. Don't put like the wrong x with the wrong y, because then it makes it more difficult for the examiners, but also you may lose marks. So I'm just going to double check those now by plugging both of those answers in, or actually I could just do one. If I plug 1 and 2 in to the top equation here, and check that works, almost certainly the second one will as well. So 2 times by x was 2, so 2 times 2 squared plus 3 times 1 squared is 11. Okay, you could check it with the other one as well, but pretty sure that would work. Very confident that will work as well. Right, next question. I said yesterday this kind of looks like a bearings question, but I don't think it is on closer inspection. I think this is going to be a 3D trig or Pythagoras question. So the diagram shows a triangle ABC and a flagpole BF. Okay, so first thing I want to do here, to be honest, is join these lines up. Okay, now this may be useful, it may not, but on the understanding that this is a 3D image and expecting where this is going to go, that might be helpful just from a visualization purpose as well. BF is vertical. Make sure all these measurements are on the diagram. It looks like they are. D is the point on AC such that angle B, where's D gone? BDC. D is the point on AC, I see, such that angle B to D to C is 90 degrees. Right, so we need to put that information on there. That is not included. So we need to do a line probably like that. Okay, and then I'm going to put my 90-degree angle on here. Right, so B to D to C is 90 degrees. Work out the size of the angle of elevation of the point F from the point D. Okay, so, sorry, keep saying okay, I apologise. What we need to work out here is this angle here. Right, so first thing we're going to do here is I want to work out one of these angles. Specifically, if I can work out this angle, I've got 3 sides of a triangle here, so I could use inverse cosine rule to work out this angle. I know I can do that. I can then use right angle trigonometry to get this, and then I can use this side and this side with right angle trigonometry again to get this angle here. Yes, because this is a plane, this is a flat plane, and this is perpendicular to the ground. So that should work. Okay. Right. So, I'm just going to quickly have a check. and then I will what I will do is, well, I'm just going to quickly check and think about this another few seconds to see if there's another way that I could do this, which is a bit simpler, because there's a lot of things to do there, and it's going to take a little bit of time. I don't want to spend too much time, especially if I'm on a test, thinking about other ways to do it, but I also don't want to waste any time if I don't need to. So, ABC points on horizontal ground, BF is vertical, so that has to be perpendicular to that. Yeah, that's fine. Size of angle elevation of point F from the point D. So that is the right angle. I think that that is probably the best way to do it. Yeah. Can't think of another way at the moment that would be easier. Okay, let's get started then. So, cosine rule is at the front of the paper, or the start of the paper. So I'm just going to, what I'm going to do, I'm going to go up to the top of the paper, I'm going to print screen it. Is that working? I don't know what you can see at this point, so hopefully you can still see the screen. Right, scroll that down. Now on the formula sheet is the cosine rule, not the inverse cosine rule. Oh, it's copied it down there. Why is that being difficult? Let me zoom out a second. I'll put this over here. Right, so this is your standard cosine rule for working out a side. We don't want a side, we want an angle. Okay, zoom this back in a little bit. So I'm going to rearrange this. Okay, now I say rearrange. You could either rearrange it first of all, but some people might find it easier to substitute the points in first, or the numbers in first, and then rearrange it. Okay, now the important thing here is if I want this angle, then this side is going to be A. That has to be A, the others will be B and C. Lowercase a is opposite capital A, which is the angle you're trying to work out. Okay? Right, so next thing I'm going to do is, let's plug the numbers in. Let's do it the easier way, I think. So 9 squared equals 11 squared plus 16 squared. Don't know why I decided to write that there, there's no space. Let's move that over a little bit. Okay, 11 squared plus 16 squared minus 2 times 11 times 16 cos A. Okay, now from there I'm going to work out all of these squared numbers. So this is 81. Let me get rid of all of these dots as well because they're annoying me. So 81 equals 121. And then 16 squared is 256. Minus 2 times 11 times 16, which is 352, cos A. So I'm going to simplify that again. I'm going to get 81 is 121 add 256 is 377, minus 352, cos A. Okay, so 81 minus 377 is minus 296. Equals minus 352 cos A. I'm going to then divide by minus 352 on both sides. And I get 37 over 44. Now this question, you can't see it, but if I scroll down, does say correct to 1 decimal place. So I'm not expecting nice numbers all the way throughout this. Do you know what? I'm going to actually get rid of these lines as well because I don't think they were particularly helpful. So that's cos A. So we're going to do A is cos minus 1 of 37 over 44. Okay, so I'm going to have to write this somewhere else. I'll put this down here. You can't see that, let me scroll down. So A equals, make sure your calculator has the D icon at the top, which stands for degrees, because otherwise your trig functions, cosine and tan, won't work, and you need them to be able to work. So 32.8 I'm going to put 32.76 ... Keep that answer on your calculator because we're going to need it in a moment. Right, now this is 32.76 ... I presume you meant to type in 37 over 44 unless I've made a mistake. No, yeah, okay. But yeah, the other thing to do is to leave it as that arc cos 37 over 44 and just reuse that when you need to later on. So next thing, I'm just going to clean some stuff off the diagram here. I need to work out this side here, that one. Okay, so I've got my right angled triangle here, B, D, and then C. I'm going to get rid of these labels so it's not confusing. So I'm going to use right angled trigonometry here. I've got opposite and I've got the hypotenuse, so that's sine. And if you were watching yesterday's stream, some people use these triangles so you don't have to rearrange, but it doesn't matter. Okay, either way you do it, doesn't matter. I'm working out the opposite, so I'm going to do sine times the hypotenuse. Okay, so I'm going to do sine of 32.76 reoccurring. Well, not reoccurring, but that decimal that continues, sorry, not reoccurring, times by, and then it's the hypotenuse, which is 11. That's going to give us the opposite side. So, make sure my answer is what I want. It's not. So, arc cos 37 over 44. That gives me my angle, 32.76. Sine of that times 11 gives me 5.95 ... Okay, so just keep that answer on your calculator. Didn't a similar question come up in paper 1? I don't think so, not on this one. I mean, it was yesterday, and I may have forgotten, but, or maybe it was on, you're talking about this specific year, like 2026 paper. It may have done, I don't know, I haven't seen the paper. Right, so we've got that is B to D, we've got 10, so now we're going to work out this angle here, and if I redraw this triangle to make it a bit easier to visualise, what we're working out is this angle, that's 10, this is 5.95, which we've just worked out. So we're going to work out that angle. This is the opposite, this is the adjacent. Okay, I'll just get rid of that hypotenuse there, clean that up a little bit. There we go. So now we're going to use opposite and adjacent. So that's going to be tan. So our tan triangle, if you use them, looks like that. So we're working out the angle, so we're going to do tan minus 1, opposite over adjacent. So tan minus 1, and then the opposite is 10 over 5.95 ... Okay. The dot instead of an x for times. Well, to be honest, at GCSE level and, well, maybe less so A level, but GCSE level, I would say that I think it would probably be easier for people marking it to put a times, just because it's easier to see and you don't want people to miss it. It's also unusual for someone to put a dot, so they might miss it because of that. So I would put a times at GCSE, but A level I think it would start to become more, not acceptable is not the right word, but people that are marking would be more used to it because the level of mathematicians generally that you're marking is higher. It's not something that's so unexpected to see, whereas at GCSE it might be more unexpected to see and people might miss it as a result, which obviously you wouldn't want to happen, I wouldn't want to happen. Right, so yeah, 59.2. Okay, next one, moving on. 23, 24 looks very interesting, I think, and 25 looks interesting as well, because that's about bounds. So yeah, nearly there. but these questions do take a little bit of time. You want to make sure, if you're someone that's aiming for an 8 or a 9, that you are giving yourself enough time to have a go at these questions properly. So you want to get through probably the first half of the paper in somewhere between, so not exclusive to, but somewhere between, I want to say, it's a 2-hour paper, isn't it? Probably about 45 minutes, maybe 45 minutes to an hour. Actually, the first half of the paper in probably 45 minutes, to be honest, because these questions are going to take a little bit longer in terms of working out as well and thinking. Right, hopefully you can read that question all right. So the volume of the cuboid is 13 plus 6 root 5. Without using a calculator, this basically means just show all your working, find the value of x. Give your answer in this form, a plus root b. Okay, so we know the volume, we know this is a cuboid, although it kind of doesn't really look like a cuboid because of the slant. It kind of looks like a parallelogram, but then as a... I can't think of the word. How have I lost the word? A prism, like a parallelogram prism, but it's obviously not, we're told. It's not. Read the question is the thing, just in case you're not sure. Even though there's sometimes a lot of words and you don't want to read the words because you're mathematicians. I'm waffling. Right, this times this times this. So 2 root 5 minus 3, and then we've got to times x, and then times x. That is equal to 13 plus 6 root 5. Okay, so we've got 2 root 5 minus 3, I can't write, and then times x squared equals 13 plus 6 root 5. We're going to divide both sides by 2 root 5 minus 3. So x squared is equal to 13 plus 6 root 5 over 2 root 5 minus 3. Now from there what we need to do is rationalise that denominator so that we get something which is a bit nicer, and hopefully we can then square root a bit easier. So 13 plus 6 root 5 times by 2 root 5 plus 3, and then over 2 root 5 minus 3 times by 2 root 5 plus 3. So we're multiplying there by something called the conjugate, which is the same thing, just the sign flipped. So minus to a plus, and what that will mean is the denominator will simplify to something which doesn't have a square root in it. So x squared, I'm going to zoom this in a little bit because I'm writing a bit smaller. X squared is equal to, now we're going to multiply out these brackets, so I'm going to not draw all the lines here because, to be honest, if you're at this point, you should probably just be able, or most people, not probably, should be able to, most people will be able to do this visually without drawing the lines, okay? But obviously, if you're struggling, do that. So 13 times 2 root 5 is 26 root 5. Don't need the calculator for that. Don't know why I picked it up. 13 times 3 is 39. 6 root 5 times 2 root 5. 6 times 2 is 12. Root 5 times root 5 is 5. So we've got 12 times 5, which is 60. 6 root 5 times 3 is going to be 18 root 5. On the bottom, 2 root 5 times 2 root 5. 2 times 2 is 4. Root 5 times root 5 is 5. 4 times 5 is 20. Minus 3 times 2 root 5 is minus 6 root 5. And then we've got 2 root 5 times 3, which is plus 6 root 5. They will cancel. That is the whole point. Minus 3 times 3 is minus 9. So that gives us x squared as, I'm going to simplify the top, simplify the bottom. 26 add 18 is 44. And then we have got plus 39 add 60 is 99. Sorry, I forgot the root 5 after that first bit. Over, these cancel. 20 minus 9 is 11. Okay, so Then what we're going to do, we can simplify that a little bit more. I'll do it over here. So 44 divided by 11 is 4 root 5, and then plus 9. Now this next bit is probably where the trickiest bit of this question is, to be honest. It's because what we've got is x squared equals 4 root 5 plus 9. Okay, it's then about square rooting that, or figuring out what you would square, basically, to get this. So, there's a couple of ways we could do this, to be honest, and you could do a bit of trial and error. Probably the nicest way to do this, I think, would be to write it like, instead of x, we could have x as being a plus b root 5. I mean, this is the way that I'm thinking at the moment of tackling this bit. What we can do then is then expand this and compare what those numbers would have to be to make this work. Okay. It might be pretty straightforward. I might be overthinking this. I mean, it might be as simple as 2 root 5 plus 3. But that's not going to work because that's going to give me 6 root 5 and stuff. Yeah, so that's not quite going to work. Right, so expanding this, we get a squared plus 2ab root 5 plus it's going to be 5b squared. Okay, so what we then get is now I know it's got to have this format because this has got a root 5 in, so I'm not going to be able to get a root 5 in any other way. So here, what I'm going to do is I'm going to put my constants together. So a squared and 5b squared, and then plus 2ab root 5 is equal to 4 root 5 plus 9. What that tells me is 2ab is equal to 4, and a squared plus 5b squared is equal to 9. Right. From there, what do I want to do at this point? I could substitute in. There's probably an easier way to do this, to be honest. I'm probably making this more difficult, but I'd rather explain to you how I would approach these things. And I'll have a look at the mark scheme in a second, and I can explain that bit as well. You know, if you've got an easier method or something you think might work in the chat, feel free to put it down below. Right, let's divide both sides by 2. We get AB is equal to 2. So then we get that A is equal to 2 over B. Right, I'm not loving this, I'm going to be honest. Let me reevaluate this. So x squared, we are looking for value of x. It tells us it's in this form. So maybe what I do is change the format of what I was doing to a plus root b. I'm going to do that because I think at the moment this is getting a little bit too complicated, and it's something I could do. You know, it's not something that won't work. It will, but at the moment it's just going to take too long and probably lose too many people, which isn't what I want to do either. So let's try this again and use the format they gave us. A plus root b. Okay, so that's going to give us a squared plus, then it'd be 2a root b plus b squared. Not b squared plus b, because root b times root b is b. Okay, that is 4 root 5 plus 9. Yes, this is a lot easier. So we get a squared plus b, there our constant term, plus 2a root b. Okay, equals, I'll just swap the order here just so it matches up a little bit nicer. If I use some highlighters here, this bit has to be 9, and what highlighter shall I use? This bit has to be this. So that second bit basically tells us what a and b are. So 2a root b is equal to 4 root 5. So we get that A is 2 and B is 5. Okay, so that means our answer, if we go back to this point, we get 2 plus root 5. Okay, which again, actually, with a little bit of trial and error, I probably could have worked that out. So that might have been quicker. But either way, you know, that method works as well. The other method would have worked, would have been a little bit longer and not as, probably as straightforward because they gave us that extra information. Right. Okay, hopefully that makes sense, even though it took a little bit longer to go through it. But, you know, I'd rather be honest with you about how to approach these questions and different ways you can do it. But also, you know, little things like that about, okay, thinking this is seeming a little bit too much that I'm doing. Have a look back at the question. You know, those little things. Right, this question. I don't love the look of this, I'm going to be honest, because it's got no diagram and it's about a kite, and typically people don't love also the questions to do with straight lines. They're not the most popular. Right, AB is equal to AD and CB is equal to CD. And what that tells us is the opposite sides of the kite. So if I do a quick sketch over here, so a kite is typically looking something like this. Okay, hopefully you've all flown kites at some point and know what the general look of, well, should know anyway from a mathematical perspective, but you've got an idea of what one looks like. Now the other thing to know about a kite is, well, these angles should be the same. These angles at the top and the bottom will be different, but here they will be meeting at right angles, these lines between the lines between the opposite points. Yeah, they will meet at right angles. And again, if you've flown a kite, you will probably know that if you've flown one of this shape, because that's the way that quite often the poles go to hold it together. Right, or the sticks, or however it's done. A is the point with coordinates. This bit doesn't really tell us anything in terms of position or like where they are, because you don't know which one's which at the moment. So A is the point -2, 10. B is the point with coordinates this. C is the point with coordinates 4, -5. I think let's work out a gradient between the two. So gradient of A, B is going to be, we're going to do y take y, 10 take 4, over, and you've got to take these away in the same order, -2 take away -27 over 5. Okay, so that will give us an answer. So these gradients have to be the same. So that's 30 over 17. And that isn't particularly nice, so maybe it's A and C that have a nice gradient. Right, let's try that. So we're going to do 10 take away -5 over -2 take away 4. -5 over 2, that's a bit nicer. So -2.5. Okay, and then we do need to do the third, we do need to do another one. So I've got A to B, A to C. Let's do B to C, because then we'll see one of these basically will match up with the other one, and then there's one that's left over, and then we can kind of get an idea of whereabouts on our sketch they would be. So here I'm going to do gradient of, let's just go with B to C. I think actually that's, I don't think there's any other one I could do. So that's going to be 4 minus -5 over -27 over 5 -4. I don't know what this spam is in the chat, so I'm just going to delete that. So I don't know what any of it means, so that's the reason why. Okay, so that gives us -45 over 47, which I'm going to just check what I've done here now, because I don't love that either. That doesn't seem right. So essentially we've got, let's say A's there. And we could have it like that. Okay. Let me just make sure I've done these gradients right. 4 minus minus 5, minus 27 over 5, minus 4. 10 minus 4, minus 2, minus 27 over 5. A to C, 10 minus minus 5, minus 2, minus 4. Okay. Ah, right. I've got this information up here that I forgot about. So, let's say AB is equal to, that will, AB is equal to AD, and CB is equal to CD. Right, do you know what? I probably don't even need to do the gradients. So, I've got these points here. So, A minus 2, 10. Now, obviously, this isn't accurate because this could be a different orientation. B minus 27 over 5 and 4. C, we've got as 4 and minus 5. Okay, now again, this obviously isn't accurate. Right, but what I do know is that the distance... Right, how many marks? Let me check how many marks this question is first of all. I'm thinking about how much I need to do here. 6 marks, right, so we probably do need to do a lot. So what I'm thinking now is these gradients might be a little bit helpful. So, I need to do A to C, I've got, that's why that's a nice gradient. Okay. So I can work out the gradient of A to C. So I've got the gradient of A to C. I'm going to do the equation, sorry, of A to C. So, equation of A to C. Now, I'm going to use y equals mx plus c. So y equals minus 5 over 2 x plus c. Now I'm going to substitute in one of these points. I'll go with c, 4 minus 5. So minus 5 equals minus 5 over 2 times 4 plus c. So minus 5 equals minus 5 over 2 times 4 is minus 10 plus c. Add 10 to both sides, we get 5 equals c. So AC is equal to y equals minus 5 over 2x plus 5. I'm just going to double check that works with minus 2 and 10 on my calculator. So if I put in minus 2, I should get 10. Yes, that works. Right. That's important, that bit. Now here, I know this is perpendicular. So B to D is perpendicular. So B to D is going to be y equals the negative reciprocal. So because it's perpendicular, so it's going to be 2 over 5x plus c. And then we have to substitute in the point B. Okay, so B was, sorry, I've forgotten it, minus 27 over 5 and 4. Ugh. Let's put this over here. B is minus 27 over 5 and 4. Okay. Right. So we're going to plug that in. 4 equals 2 over 5 times by minus 27 over 5 plus c. Please be a nice number. Let's see. 2 over 5 times by minus 27 over 5 is minus 54 over 25. Not a nice number. Okay, so we're going to add that to both sides. So I get C is 154 over 25, which is not nice. So BD is equal to, or is rather, colons, y is equal to 2 over 5x plus 154 over 25. Right. So, I've got this line here. I know it goes through that point. Now, what I could do is find out where this point is and then do the same on the other side. So I could find out where they intersect and what this point here is, and then work out the difference in x, difference in y, and then do the same on the other side. That would get us to the point D, because these lines from B to the centre and the centre to D have to be the same length. Again, don't particularly love that. Right, I think that's definitely one way to do it. Can I think of another way off the top of my head at the moment? No. Because although this line here, A to D, looks perpendicular to A to B because the way I've drawn it, it's not necessarily. So it'd be helpful to work out that point at the centre. Let's do that. Let's do that. Let's do that and just get this question over with. But yeah, 6 marks, so it is going to be a bit difficult. And I'll check the mark scheme out afterwards, see if there's another way we could do this as well. Always helpful. So, because these are both equal to y, I can just put minus 5 over 2x plus 5 equal to 2 over 5x plus 154 over 25, and then solve it. So let's do that. So minus 5 over 2x, and then I think it's plus 5, equals 2 over 5x plus 154 over 25. Okay, so let's add 5 over 2x to both sides. Okay, so we're going to get 2 over 5, add 5 over 2 is 29 over 10 x. Right, going to subtract 154 over 25. So 5 minus 154 over 25 is minus 29 over 25. That actually doesn't look too bad. Divide by 29 over 10. We get x is minus 2/5. Okay, and then if we plug plug x into either one of this or this, we'll get y. Okay, so I'm going to put it into the left-hand one. So I'm going to do y equals minus 5 over 2 times minus 2 over 5 plus 5. So y is equal to, and I think if I've done the maths right there, it should be 6. Yeah. So that's where they intersect, which is nice because then we can just do, I'm going to write that on the diagram. So it is, sorry, minus 2 over 5 and 6. Now what we can do here is look at the change in the x and do the same on the other side, and look at the change in the y and do the same on the other side. So y is easy, it goes from 4 to 6, so this has to be 8. Okay, and then the next bit, I need to work out how I get from minus 27 over 5 to minus 2 over 5. So essentially I could just look at the 27 and the 2 bit because the denominator is the same. So 27 take away 2 is 25. It's gone up by 25 over 5, which is 5. So minus 27 over 5 minus 2 over 5 is minus 5, but we've added the 5 because we've gone up. So minus 2 over 5, add 5 is 23 over 5, which is what the point D should be, 23 over 5 and 8. And I will just make sure that is correct for you, but the numbers are nice. So 23 over 5, they've got 4.6, that should be the same it is, yeah. Now, just having a quick look at the mark scheme here. Got the gradient, did the same thing as us. A bit difficult to read this mark scheme in particular. Right, yeah, got the equation. Put the equation equal to each other, solves the equation, gets the coordinates of the intersection, and then does it from there. Yeah, it's the same thing as I've done. But yeah, really not an easy question, that one. Okay, next one, last one. A solid sphere has a radius of 2.8 centimeters, correct to 1 decimal place. Okay, first thing I want to do is, because that's 1 decimal place, I'm going to do lower bound and upper bound. So lower bound is going to be 2.75, upper bound is 2.85. Okay, right, I'm just going to quickly check how many people we got. We've got 9. I'm going to do at the end, people, if you are watching this now, or go through. There's a vectors question someone asked me about. I don't know if they're still in the chat, but one of those complicated vectors questions, I think that's a good idea to do. There's also one of those on my channel, so I can maybe point that out to you as well, so you can have a look at that one. And I'm going to talk about, very briefly, and you can tell me if you want me to do any of those questions, but questions, the things that I would expect to come up on paper 2. Right, let's read the rest of this. The sphere has a mass of m pi grams. Don't forget that pi. M is 260 to 2 significant figures. Now here, because our number is got 3 digits in this case, it's in the hundreds, 2 significant figures means rounded to the nearest 10. So lower bound of this is going to be 255 and upper bound is 265. Okay, if you're interested in bounds and, or I don't know, who's interested in bounds? Probably none of you. You probably just want to do your GCSE and that's it. But it's always an interesting one when you have a 10 rounded to 1 significant figure. What's the lower bound and the upper bound of that? So, you know, you might think, okay, well, the upper bound is 10.5, but actually 11 to 1 significant figure would still be 10. And the lower bound is the easier one, which is 9.5. But because that's on the boundary between a change of position from units to tens, it has this difference where actually these aren't right. The upper bound is actually 15. And so it's not equal there, which is quite interesting. But also, if they wanted to do something sneaky, could do something like that. Okay? But in this scenario, that's not the case. Right. Back to the question. I'm digressing again. So, do the bounds as you're working through. M is either 255, 265, or somewhere in between. Actually, it can't be 265, less than 265. Work out the upper bound for the density of the sphere. Now, if you're not sure about how to work out density, if you forget the units, give it away. Okay, it's mass. Density is mass divided by volume, or you could make that into one of the triangles that most people probably do for density. Density is mass divided by volume. Okay, yeah, I can do transformations as well. Not a problem. I'll do that after this question. So, upper bound for the density of the sphere. Okay, now, density, we need mass and we need volume. We've got a solid sphere with a radius of this. What we need to do is work out the volume of that sphere, and if you can't remember or you didn't know this, the formula is on the formula sheet, so we'll get that. I mean, I know it off the top of my head, but just so you see it as well. It's 4/3 pi r cubed, okay, the volume of a sphere. 4/3 pi r cubed, so let's go back down. So, volume, 4/3 pi r cubed. Tried to make that better, probably made it worse. Right, now we need to think about what we need here. Because we are going to do, for density, we want the upper bound of density, so we want the biggest answer for density. So we want, if you want the biggest answer for density and we're dividing, we want to do a bigger thing divided by a smaller thing, because then more of the smaller thing go in to a bigger answer, so you get a bigger answer. Sorry, to a bigger number, so you get a bigger answer, if that makes sense. So if you think, if you're going between 4 and 5, and you go between 2 and 3, you'd want to do 5 divided by 2, because that would give you a bigger answer than 4 divided by 3. Maybe try some numbers out if you're not sure. Or, if you're not sure with the bounds question, work out all of them, all the possibilities, and just then go with the right one. Okay, that's another foolproof way of doing it. So we want the biggest mass divided by the smallest volume. Now, to have the smallest volume, because everything in here is timesing, we want to have the smallest radius, which is 2.75. So we're going to do 4/3 times pi times 2.75 cubed. Okay. Now this question, I think, on the face of it, looks easier than the last one. So don't get put off necessarily by the difficulty of the question and then going on to and thinking the next one's going to be harder, because it very well may not be. Okay, so we get this. Yeah, that is right. That's our volume. There'll be marks for getting that. Then we need to do the mass. We need the biggest mass, so we need 265 pi. So density is going to be 265 pi divided by 1331 pi over 48. Okay, and that fraction is on the bottom of this main fraction. Okay. So let's put that in the calculator. 265 pi over brackets fraction 1331 pi, or the answer button, over 48 gives us an answer to 2 decimal places of 9.56. Okay, grams per centimetre cubed. Okay, let's just double check the units. Yeah, everything was centimetres. Was the mass is in grams, right? So that's fine. Okay, just double check that answer for us, just to make sure that is right. Yes, 9.56. Okay, so that's it. That's the paper done. I would say it was a difficult paper. That was more difficult than paper 1. But I mean, it's hard to say whether paper 2 is going to be the same, easier, harder. I wouldn't necessarily expect it to be easier based on what I know. I would expect it either to be kind of the same or slightly more difficult, but don't worry about that. So what I would also say is, don't worry if tomorrow you come out of the exam, or don't overly worry if you come out of the exam and you think that was difficult, because I would expect tomorrow to be more difficult than the first one. The reason for that, I think there were, from what I understand, from what I'm told, people tended to find the first one, from what I've heard, more straightforward and actually not too bad. That could be my experience, and it might not be everybody's, from speaking to people. So the IGCSE one I would expect to be, the higher paper I'm talking about now, slightly either the same or slightly trickier. Now, look, the other thing to mention there as well is, all of that difficulty, etc., whether it's the same, easier, harder, whatever it is, will have an impact on grade boundaries. So it's very difficult to come out of the exam and say, okay, you know, if you've done what you would expect to do and done how you would expect to do, then it may be that you know, if you found it really difficult, that everybody found it really difficult, or if you found it really easy, that other people found it really easy. So really, it's hard to tell how you've done if you've done as you would expect, because what they would do is compare to everybody in the year, the whole cohort of people sitting that paper. So it's really difficult. And I can see somebody in the chat as well saying paper 1 was hard, and like I say, that may just be the people that I've spoken to, and I don't know everyone who I was speaking to, what grade they were going for, or everything like that. So, you know, if you found it hard, maybe it was hard. Maybe that's just the information that I've got, and maybe it'll be easier this one. It's really hard to tell, to be honest. You can't know. But I suppose what I'm trying to say is, if it is difficult, tomorrow's one, don't come out of it and think that it's the end of the world and everything's gone wrong and you're not going to get the grade you want, etc., etc., because it's really difficult to tell. And the main thing is with all these exams is once you've done it, it can be really hard to try and forget about it, especially if it's not gone the way you want. But actually, it's really important to try and forget about it because what you don't want to do is that one impact others. Is one thing I would say as well. And obviously, well, I assume everybody, I presume and assume everybody watching this now will have other exams to do. So do as well as you can. I'm sure you will do well. If you're watching this, you obviously want to do well because you're putting the time in and the effort in. So yeah, good luck. Now I will go through some of those things people have asked for. So there's a vectors question and a translation question. So what I'm going to do, I will find quickly a vectors question, and I'll go through that. They shouldn't be too hard to find. They tend to come up, I would say on average about every year, so I would expect one to come up tomorrow. Part of that question I expect would be straightforward, part A. Part B I expect will be this complicated, I'm going to be honest, complicated vector method. Okay, right, so let me have a quick look. I'll just pick a random paper. Let's have a look at Jan 2023 2H and Jan 2023 1H, and then I'll also look at the 1HR and 2HR papers. But they should be pretty easy to find, these questions, because they are at the end of the paper typically. No, can't see one on that one. Here we go, this looks something like it. Yes, right, let's have a go at this one. I will get the marking up as well for this paper. This is 1H 2023 January. So let me just find that. 1H 2023 January mark scheme, and this was question 24, I believe. I think it was the last question. Okay. Okay, right, let's do this. So scroll down. Hopefully at this point someone's still watching, because I'd hate to go through all this and explain it. And at this point the person that wants it isn't even watching. But anyway, it'll be useful. Something like this I expect to come up tomorrow. Now, this one is just the vector method. So this doesn't have a more straightforward part A. Now that might be the case. Might be the case tomorrow. I don't know. We're not going to know until tomorrow. But doesn't mean we can't go through this. People that are interested, people that aren't sure how to do it, people that want to know how to do it, I can go through it. Right, so we've got quadrilateral. Okay, O, A, E, D. O to A is 2A, that's on the diagram. O to B is 2B. D to E is 7A plus 3B. This bit of information is important, we're going to need to use that. So AB to B to D is in the ratio 1 to 2. So A to B to D is in the ratio 1 to 2. Okay, so that means this is 1/3, A to B, and B to D is 2/3 of the whole line, A to D. Point C on AB is such that OCE is a straight line. Okay, so this is a straight line. Let me draw that on properly. Hopefully this diagram does actually allow me to draw a straight line that goes through those points. No, it doesn't. A bit annoying. Vector proofs already came up on paper 1. Let me have a look from the information that I have got. Are you sure it came up on paper 1? Are you talking about the GCSE paper? Are you talking about, sorry, not the foundation paper. Are you talking about the national GCSE, or are you talking about the IGCSE? Because I don't believe, from what I've been told, there was a vectors question. I could be wrong. Anyway, I'm going to go through this because someone was asking about it. Now, you can see this line doesn't go through that point. I mean, I would have hoped it would, but it doesn't because the diagram's not drawn accurately. Right, so use a vector method to find the ratio of O to C, C to E. Okay. So this is a bit not my favourite kind of question at the moment because I don't know A to D. I've got no information about it. And I've got no way really of working it out because I've only got O to A. I've got O to B. I mean, I can do A to B. I don't see a way I can get from B to D. No, I do, obviously, because I've just said it. I can get from A to B. And then B to D is 2/3 of the whole line, so it's going to be double A to B. Right. Come on, Mr. Talbot, switch on, switch on. Right, so A to B is going to be minus 2A plus 2B. Okay, minus 2A because you go in the opposite direction. So that is 1/3 of the whole line. 2/3 is B to D, so just double it. So double this, I'm going to get B to D is minus 4A plus 4B. Okay, so then I could do as well A to D, because that will be these two added together. So it's minus 6A plus 6B. Okay, right, that's helpful. Right, if it's on a straight line, then there is basically some amount of... What I'm going to do now, I'm going to just get rid of this. I'm going to try and explain this with a bit of highlighting. I also want to work out O to D here, to be honest. Let's do that first. O to D. So that is going to be 2B, okay, and then plus B to D. So B to D is minus 4A plus 4B. Okay, which simplifies to minus 4A and then plus 6B. Okay. Right, so there's two ways. Basically, we have to do this two ways and get simultaneous equations and solve them. So the first way I'm going to do this is I am going to do, I'm going to go from O to C in two ways. I keep saying that's like the third time I've said it. The first way is to do a fraction of this line. Okay, so work out O to E and then do a fraction of that line. Okay, so O to C, I could say is a fraction, I could say lambda of the line O to E. The other way that I could do this, and I'm going to kind of split this up, is I could do O to A, sorry, I'm going to say O to C equals O to A, the other way, I'm going to highlight on this. Didn't mean to do that. There we go. The other way is going O to A and then doing a fraction of this line, okay? Because I don't want to go all the way along that. What I want is to just go up to the point C, okay? So O to C equals O to A plus a fraction, I'm going to use this weird letter mu, of A to D. Okay, a fraction of the line A to D. Okay. You could also do A to B, to be honest, doesn't really matter there. Right, so now let's do that. Let's replace some of these things. Now the first thing I do need to do is to work out what O to E is. So O to E is O to D plus D to E. So minus 4A plus 6B and then plus 7A plus 3B equals 3A plus 9B. Okay. So this is when it starts to get quite algebraic, but we'll do it. So O to C equals lambda times by O to E, which is, I'm just going to remove this and put a bracket there instead. So brackets 3a plus 9b. So but this is essentially the way you always need to do these questions. You need to have two ways of getting from one point to the other point you need to get to. Okay? That's how we're going to do it. And we're essentially going to use lambda as our fraction of the line O to E. Once we've got that fraction, we can then work out what the rest of this must be. Excuse me, and then write it as a ratio. Okay, but you need two setups here, two different ways of getting to that point. So the other one is O to C equals O to A, which is 2a, plus mu lots of A to D, which is minus 6a plus 6b. So that is, I'll do this side first of all, 3 lambda A plus 9 lambda B. Okay, 2a plus, or I should say minus actually, I'm going to do minus 6 mu A plus 6 mu B. I'm going to collect my A terms here, so I'm just going to put 2 minus 6 mu in a bracket, and then A at the back, and then plus 6 mu B. Now there's normally one easier one of these to compare. Now basically what I'm going to do, I'm going to compare the A's and I'm going to compare the B's. So the B's, 9 lambda and 6 mu. We're going to compare those, okay? So those things in green and in blue have to be equal. So I get 3 lambda equals 2 minus 6 mu. And the other thing I get, which is easier to use, at least at the start, or manipulate I should say, is 9 lambda equals 6 mu. So we want to get mu equals, or mu as a subject or lambda as a subject, doesn't matter which one, and then we're going to substitute in and solve for the other one. Okay, so let's divide by 6. I'm going to get mu is equal to 3 over 2 lambda. Okay, that's equation 1, that's equation 2. Equation 3, I'm going to plug this into here. Okay, so substitute, can't see that, my head's in the way. Equation 3 into equation 1. So we're going to get 3 lambda equals 2 minus 6 lots of 3 over 2 lambda. So 3 lambda equals 2 minus, then 6 times 3 over 2. Is 9 minus 9 lambda. Add the 9 lambda to both sides. We're going to get 12 lambda is equal to 2. Divide by 12 and we get 2 over 12, which is 1 over 6. Now actually lambda here is the only thing we need, because if I go back up the top, I wanted lambda because I want to know what fraction OC is of OE. So this bit here, if I just get rid of the other highlighting, that bit is 1/6 of the whole line. That's 1/6. This must be 5/6 therefore. So then you put your numerators as the ratio. So the ratio is 1 to 5. Okay. So I haven't got the answer here, the space for the answer, but the answer is 1 to 5. Okay. Is geometric series on it? No. Quadratic isn't? No. Quadratic is on the national GCSE. It's not on the IGCSE. It's on further maths. Well, it's on other further maths papers. So for what you'll be talking about, Jenna, Jenny, if you've heard from other people, they may have been talking about a further maths paper, but it's not on the IGCSE higher paper. Right, okay, next thing I was going to do is translations. Someone asked about that. Do you know what? Let me quickly find my predictions for what is going to be on there. So just give me one moment. I'm just going to look for the slide in the video that I did just so I can share that with you. Last minute revision. Here we go. Paper 2 predictions. Right, so I'll just copy these over. This is higher paper 2. Now these are all the things I think are likely to come up based on what I understand was on the first paper. That's gone really big. So this is what was in my video, if you haven't seen it. So these are the things I think are likely to come up on the higher paper 2 tomorrow. All of those things on the screen I think are likely to come up. The ones at the top I just think are more likely to come up. Okay, so I think there's a good chance everything on there comes up. I think vectors is very likely. I think cumulative frequency is very likely. I think there's going to be some ratio on there. Angles and polygons I think is very likely. In terms of things at the start of the paper, ratio, interquartile range, averages from a frequency table, constructions could be on there. Make sure you got your compass and your protractor. And then things which are likely to be at the end of the cumulative frequency, probably be at the starter in the middle, angles and polygons, same, at the starter in the middle, circle theorems probably in the middle or towards the end, vectors almost certainly towards the end, arithmetic series, if that is on there that will be towards the end, equations of straight lines towards the end, non-linear simultaneous equations towards the end of the paper, graph transformations, so that could be on there. Probably from about the middle of the paper, somewhere around there. But yeah, all of those things on there I think are likely. What I would say is there's not going to be all of these things at the end. You might have noticed I said a lot of things at the end there. So I think if I was putting all those things into a paper, you could have theoretically you could have all those things on a paper. I think things that could be at the end: vectors, functions, although functions at the end doesn't necessarily mean it's hard, arithmetic series, equations of straight lines, non-linear simultaneous equations. There's 5 questions there could be at the end. I mean, that is not unheard of. I mean, done questions tonight up to 25, probably, to be honest, from 20 onwards, probably difficult. So not unrealistic, but yeah, I think they're the most likely things to come up. Right, I'll just quickly talk about the foundation one as well. So if you're someone doing foundation, I think these things are likely to come up. Scroll down a sec. Guys, so shape transformations I think is really likely to come up. And that could also be in the crossover, but it doesn't have to be. So it could, by crossover I mean that could be on the higher paper as well at the start. Sequences, so nth term, ratio again, averages from a frequency table, volume and surface area, constructions. So things on there that could be on the higher paper as well. We're talking sequences, ratio, shape transformations, averages from a frequency table, volume and surface area, constructions, similar shapes, factorizing, solving quadratics, products of prime factors, Pythag, basically everything on there. I don't think there's any exceptions, maybe apart from bar charts, could just be on the foundation. So all of those things apart from bar charts, I believe, could also be on the higher paper, which is why I think they're likely to come up, because you've got this crossover. There are questions at the end of the foundation that are on the start of the higher. So yeah, again, if you're someone who is aiming for, let's say, a pass, a 4, okay, a 5, a 6, then these topics, if you're not sure, make sure you know them. Make sure you spend some time on them, having a look before tomorrow, just recapping how to do them, because they shouldn't be too difficult, okay, especially if they're at the start of the paper, but just recap them. that would be very worthwhile doing. Right, I think, oh no, I need to do translations. Let's quickly do that, and then that would be it, I believe. So, where's Maths Genie gone? Maths Genie is really good. Transformations, let's do a translation question. Let's quickly do a translate one and a describe one. And then I will call it a day, unless anyone's got any other questions they would like me to go through, or anything they want me to explain. I'll just see, there might not be anybody else watching at this point, but let's have a look. People still watching? Yeah, 9 people are. 9 people are, that's good. 11, thank you very much for watching, but not really for me, but hopefully it's helpful. Right, let's do this. So, single transformation. With all the transformations, you need to say which transformation it is. Here, this has clearly been moved, okay, up. So we're going to write translation. Now, to remember all the transformations, someone told me this one time and it just kind of stuck with me. Terry. Okay, so translation. Enlargement. Not spelling that, I'm writing it very well. Rotation. Rotation. And reflection. And the last one just means, yes, I've remembered them all. Okay, the last letter is a bit of a weird one, but it's just, it works, I remember it, so if it works, it doesn't really matter. Anyway, that's how to remember all your transformations. So you have to specify which one it is, in this case translation, and then for translation we just need to say by, and you could just write the vector at this point. I'm going to write by the vector, and then this, if I look at just one point, there to there, that has gone 1, 2, 3, 4 down. So we do a number at the top and we do a number at the bottom. Now, number at the top is X, number at the bottom is Y. This has been moved, nothing left or right. It stayed in the same place. So our X is 0. It's gone down from, if we're going from A to B, and do check, because sometimes they're a bit sneaky and say from B to A. Okay, so A to B we've gone down 4. So that means our Y coordinate, we've subtracted 4. Okay, you subtracted 4, so minus 4. And that is a good way to remember the direction of the negative and the positive as well. Look at your coordinate. Has it gone down or has it gone up? So that's how to describe one. I might speak about enlargement, because enlargement is probably the hardest one, or not hardest, but has the most things to remember in terms of description, and there's a method for finding the centre. So this one, it goes X, Y, okay, so this is 8 to the right. If it's positive, goes up, goes right. Okay, if you're talking about your X, because your X-axis goes up as you go to the right. This is then 2 to the left. Okay, sorry, 2 down, ignore me, 2 down. 2 down. Because that's your Y, okay? I was just thinking then, that's not going to work, our shape's going to be off the page. And also, I can't go right and left. Right, 8 right. Let's look at one point here, first of all. 1, 2... I was thinking there's not 8 squares here. Look at your scale. So, 2, 4, 6, 8. Okay, and then we're going to go 2 down. So it's going to go here, because our scale, again, is 2. Now once you've got that point done, you can basically fill in the rest of the shape. Okay, 3 along the top, 2 down, 1 across, goes there, that goes there. You could also just check with another point as well yourself. So this point, 2, 4, 6, 8, 2 down. Okay, so it's going to end up here. Use a ruler to join these up. I'm not, just because of speed. Okay, and you might want to just do some light shading like that, just so it's easy to see. Okay, I'm just going to quickly do an enlargement one, because like I said, that's quite interesting and people tend to not make mistakes, but can forget how to do that if you haven't done it in a while, how to describe it. So let's quickly do that. Shape A on shape B, let's go with the harder one. Right, okay, so How to describe an enlargement. So first of all is to recognise it's an enlargement, and that's because one of the shapes has got bigger or smaller. So it's gone from 2 to 4, that's gone from 3 to 6, okay? So enlargement, we have to specify first of all which transformation it is. So enlargement, scroll that down, zoom this out actually so you can see better. My head is in the way, let me move my head out of the way. It's a bit weird being on that side of the screen, but there we go. Enlargement, scale factor, and then you need to look at the sides here. So that's gone from 2 to 4. So that's a scale factor of 2. Check with the other side. So 3 to 6. Yeah, scale factor 2. And then we need to do the centre. I'm going to write that on the next line because I don't want to put that there. So centre, we need to find the centre. This is the bit that people will forget if they forget anything. And to do this, you need to get your ruler and you need to go through corresponding corners. So I want to do top left, like this. You need to do it as accurately as you can and do it all the way along the grid, okay? So as accurately as you can, because if I do this now with another corner, these should cross. But the point these cross at, you need to be able to see. So I'll do the final corner. Now, theoretically, you should be able to do it with 2, but in reality, most people are not accurate enough to be sure after 2. So do the others as well. Right, so we can see our centre is this point here, which is 5, 6. Okay, so you need your transformation, which is enlargement, you need your scale factor, and you need your centre. Okay, right. Is there anything else that people would like me to go through? If there is, put it in the chat. I'll give you a few seconds because I think there's a bit of a delay. Tips for exam nerves. Good question. The best tips I have are make sure you get enough sleep. Make sure you eat enough. Make sure you, I mean, if you've done everything you can, remember that. Remember that you've done everything you can. Because it can be easy to let the pressure get to you. But just stay calm and believe in your own ability, because you can do it. The only things that will stop you doing it, if you've prepared thoroughly enough, is the stress. And so it should be easy. And tell yourself that it should be easy. I've worked hard. It's going to be easy. It's going to be fine. And if it's not, Sam, James, Sarah next to me is going to be finding it tricky as well. And if you get to a question in the paper that is difficult, and maybe having a mind blank. I mean, I had a mind blank today. I couldn't remember someone's name that I say their name all the time, every day. I couldn't remember their name. And so, you know, I know that's a very trivial example, but sometimes you have mind blanks. Leave that question, go on to another one, come back to it. Remember to breathe. It's a bit weird saying that, you know, it's not like you're doing a marathon or anything like that, but trying to control your breathing and remember that this is an exam. You've done all the hard work, you're going to do the best you can, and as long as you've done your best, that's all you can do. So sleep well, eat well, make sure you're prepared in terms of like got your equipment sorted, because what doesn't help nerves is rushing around, not having, you know, having your blood sugar being low, being overly tired. One thing I like to do is get up early, so go to bed early, get up early, because then I feel more awake and alert, especially for the morning exams. You know, I mean, I know this now going to work, but, you know, I get into work at, I don't know, 7 o'clock. By the time it's 9 o'clock and I'm teaching, I've been awake for like 3 hours and everyone else hasn't, and I know exactly, you know, it's like I've done half the day already, and it's not really like that, but it feels like that. I feel like I would, if I got up at 7:30 at 11 o'clock, almost. Yeah, not quite the same timing wise, but you know what I mean. Hopefully you get the points. So yeah, sleep, eat, getting up early, you know, having stuff on flashcards, doing as much revision as you can, although you can't, you know, you can only do so much now. Um, and being kind to yourself and remembering that you've done as much as you can, you're doing your best, and that's okay. And if it doesn't go well on the day, sometimes that happens, unfortunately. Um, but all you can do is your best, and as long as you've tried your best, that's all you can do. Right. Sorry. But they're my tips for exam nerves. Look after yourself. Do we have to bring in our own tracing paper, or does the school give it? If you need tracing paper, you'll be given it. So don't worry about that. We can have a look at some complicated algebraic fractions ones. I'll find one of those. And compound interest and simultaneous equations. You're very welcome. I'm glad I can help. I just want to be able to help. Good, 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 good. Right, I'm glad that advice was hopefully useful and helpful. Let's do let me find an algebraic fractions one. I'm going to find a past paper one. I saw one a second ago on one of these. So let's have a look at that. Again, they'll normally be near the end. With algebraic fractions, typically what you want to do is factorize everything and simplify. Not one on that one. Let's have a look. Relatively common, I would say. Oh, there's another kite question there. Interesting. That was in 2023, January. Not there, not there. Let me have a look at another paper. Oh, the vector method question. That one. Ah, here we go. Perfect. This is exactly the kind of thing you were talking about. Right. So let's do this. Got around 65 marks. Okay, any chance of an 8? The papers, I believe, are out of 100. 65. I would need to have a look at grade boundaries. I know typically a 9 goes from about 80 to 85-ish. So, I mean, look, yeah, if you do well on the second paper, of course. Of course, yeah. Um, because let's say, and I'm just guessing at this point, I don't know off the top of my head, I'd have to check, but I'm just guessing, let's say an 8 is 75. Okay, so you'd need to get about 85. It might be less than that. It might be 70, 72, 73. So you need to average about 80%. So you'd need to be looking at like a 9 score on the second paper. But it's definitely possible. And I don't, those are just grade boundaries I've made up. So it could well be wrong as well. Do you know what? I'm just going to have a quick look because I don't want to give you that information and then have you being worried if it's not the case. So let's have a look at the grade boundaries for Edexcel IGCSE Maths 2025. They might be out. Yes, right. Let's have a look at these. See what we got. Mathematics. So, for the higher paper, last year, 2025, you needed 144 out of 200. So that is 72%. So that's 7% more than you've got, so you need to get 79% or 79 marks on the next one. Okay, which is not impossible. Right, let me put this question up first of all, and then I'll do some others, of course. Right, here's a nice algebraic fraction question. I'm going to move my head to the other side here because I don't like being on that side. Let me make me a bit smaller so I don't write on myself again. Okay. Let me just make sure I've got all of the things you want me to do. Can you do those really complicated exams? Yeah, I'll have a look at that question in a moment, Samaya. Really complicated exams. I'm not sure what you mean by the really complicated ones. Yeah, we did a non-linear simultaneous equation one earlier, so maybe just go back earlier in the stream and see. It was question. It was before that. Before that one, it was question 21. So go back and just check that out. Right, let's do this question. So, factorise everything's the first thing. Now, I'm going to tell you a little bit of a tip, a little bit of a trick here. I want to factorise this top bit here. Now, I could explode the middle. The other method you can use, if you have this calculator, okay, or there is the new version. It's all black with a gold button here, okay, where the shift is. That can solve the quadratics on the calculator. So what you could do is get the solution and then reverse the sign and put it in the brackets. That would work instead of factorising it. And they don't know whether you factorised that in your head or you've done it with a calculator. So that is a good method, to be honest. Now, I'm not going to do it that way because not everyone has got that calculator because it's a little bit more expensive. It's about £25, I think. So I'm going to explode the middle on this bit, and I'll have to do it on this one as well. So exploding the middle, I need to find numbers that multiply 4 times minus 15 to give minus 60 and add to give minus 17. So I'm going to go, I've already got the numbers, but if you're not sure, list out your factor pairs. But my numbers are going to be 3 times minus 20. They will add to give minus 17. Okay, what time am I finishing? I don't really know, to be honest, Ben. I'm just going to keep going for a little bit longer and, yeah, help some people out. As long as I can. Not crazy long, obviously, not after 9 o'clock or anything, really, but we'll keep going for a little bit longer. So, let's split the middle. I've got a video again of this on my channel. It was one of the first videos I did, actually. So, 4x squared plus 3x minus 20x minus 15. All divided by 2x minus 1 times by, now we need to split the middle or explode the middle on this bit as well. So 2 times 3 is 6. We need factors of 6 to add to give minus 7. So that's going to be minus 1 times minus 6. So I'm going to get 2x squared minus 1x minus 6x plus 3. I've split the minus 7 into minus 1 and minus 6. All divided by, now I can factorise this into x plus 5, x minus 5. Now I'm not going to do anything yet with this bit. I'm just going to leave that over here as 29 minus 4x. Okay, let me just box this bit off because that's not with that. Right, next bit of working out. So factorise the first two terms. We're going to get x and then 4x plus 3, and then on the second one we should have the same bracket, so just make sure we do get that. Let's take out minus 5, and then we're going to get 4x plus 3 again. Good. All divided by 2x minus 1 times by, here we're going to get x and then 2x minus 1. Okay, good. And then I'm going to get minus 3, 2x minus 1. Remember, you want the same bracket there. All divided by, let's check that works, minus 3 times 2 is minus 6. Yep. X plus 5, x minus 5, and then plus 29 minus 4x. Now at this point, we're starting to see some brackets which are the same, which are going to cancel. Don't cancel anything yet, because we haven't got this factorised at the top. Okay, we've got a subtract in the middle of both of them, so you can't just cross things out at this point. That would be a mistake. So now we're going to factorise out the 4x plus 3 from both of these terms, put that out the front, and then put the outside terms in a bracket. X minus 5 over 2x minus 1 times by 2x minus 1 times by x minus 3 over x plus 5 and then x minus 5, and then plus 29 minus 4x. Okay, now at this point, because I'm timesing, I could just write this all as one numerator, one denominator, and to be honest, I'm going to do that just to make it a little bit easier to explain the next bit. So you times the top times the bottom. don't expand them. So 4x plus 3, x minus 5. 2x minus 1, x minus 3. All divided by 2x minus 1, x plus 5, x minus 5. Now, oh, 1 second, I'm going to put this on. 29 minus 4x. Now I'm going to start cancelling the things that I can. So x minus 5 cancels with x minus 5. 2x minus 1 cancels with 2x minus 1. So then we get 4x plus 3 and x minus 3 all divided by x plus 5 plus 29 minus 4x. Now, in order to add this, I need to have it as a fraction with the same denominator. So I'm going to need to times top and bottom by x plus 5. So I'm going to shuffle that up slightly. X plus 5 and then x plus 5. At this point, annoyingly, I am going to need to expand the numerators again. So 4x times x is 4x squared. 4x times minus 3 is minus 12x. Add 3x is minus 9x. Minus 9. Okay, over x plus 5 plus 29x. 29 times 5 is 145. So plus, actually no, before I do that, let me do minus 4x times 5 is minus 20x. And then we have got to do 29 times 5, which is plus 145. And then we have got minus 4x squared. Which is not a lovely question at all. Actually, it might sort itself out quite nicely here. Right. Then we can add the numerators. Just be careful of the sign in the middle. In this case it's an add, so it's fine. But if it is a subtract, that applies to everything. So we'd have to do minus 29x minus 20x, which is the same as plus 20x, minus 145, minus 4x squared. That's not the case here, but just be careful, because that's an example of where some people might make mistakes. Right, 4x squared plus minus 4x squared cancels. Minus 9x, and then we have got plus 29x, and then minus 20x is 0. So that cancels with these two. And then we've got minus 9 add 145, which is 136 over x plus 5. Should be my answer. Now, one way to check this type of question is, when you get your answer at the end, you could put in any number as x, anything, apart from, well, I could put in 0, or I could put in 1. Can't put in minus 5, because that'll give me dividing by 0, but you could try anything. Do you think a question of this difficulty will appear tomorrow? Let me just have a quick look, see what I understand was on the first one. I think it could be, yeah, I think there could be something like this. I can't see from my notes of what I understand is on the first one any algebraic fractions. What did I put that in my thing? No, so I didn't have algebraic fractions in there, but yeah, it could be on there. This isn't my most this is my most likely list. There were other things in that video which I said could be on there. Yeah, algebraic fractions looks like it could be. Did you? Let me have another look. If you did, then it's less likely to be on the second one. I tried to speak to as many people as I could to find out the information. There was an algebraic probability one, I understand. Yes, there was an algebraic fractions one, yeah. I think it was a more straightforward one than that one. So yeah, less likely to come up. Less likely to come up, something like that. Right, let me see what else we've got. There was an algebraic fractions one, but it was a simplifying one. So I don't think they're likely to put something like that on the one tomorrow, because they've already tested some algebraic fractions. Not really complicated, but they have. So hopefully that answers the question. Right, let me scroll up a little bit. Compound interest and simultaneous equations. Right, compound interest is a pretty straightforward type of question. I'm just going to go to Maths Genie and grab one of those. It's fairly typical. You can have compound, like percentage, compound, not compound percentage, repeated percentage change, which uses the same like method, multiplier, etc. Right, let me just find a straightforward one here. So, this question is a compound interest question. Okay. Leanne invests 2,500 for 4 years in a savings account. She gets 3% per annum, that means per year, compound interest. How much does she have at the end of 4 years? So, what you do is we're going to write a 3% increase as a multiplier. So to do that, you do 100, add 3. So 100% add 3% because we're going up. Okay, and that gives you 103%. And then write that as a decimal is 1.03. So that's our multiplier. So we're going to do 2,500 times by 1.03 to the power of 4 because it's happening 4 times. Okay, that will give you your answer. Said answer weird then. So that is 2813. Decimal point 77. Remember, with money, you always go to 2 decimal places. Right, simultaneous equations. I'll have a look at one of those. And then there is that question to have a look at. Yeah, there was a differentiation question in there, I understand, and I think some people weren't sure that it was, because it looks like it wasn't obvious. I don't think it didn't say just differentiate. Are you doing? I'm doing well. These topics come up on IGCSE and GCSE, but the paper I did was IGCSE. Don't worry if you didn't realise. There will have been other people that didn't realise it was differentiation, and it's not an easy topic, so don't worry too much about it. What's done is done. I'd almost forget about it, but just use what you remember was on there to inform your revision. So don't worry about there being differentiation tomorrow, is the point I'm trying to make there. Right, what did I say I was going to do? I said I was going to do simultaneous equations. Let's find a straightforward one of them. I'm just double checking. There was simultaneous equations on the first paper, so I'm not going to do a straightforward simultaneous equations one. Okay, because that's almost guaranteed not to come up again. Okay, so I'm not going to do that one, Sumaya. Don't worry. I'm very confident it's not going to come up again. Okay, can never be certain, but very confident it won't come up again. Right, there was this question that you put in the chat as well. 1st of May 2012. Oh, that's an old paper. 1st of May 2012. Is it? I'll try and find it. I'll just type in rupee because the questions are wants it in rupees. So 2012. Right. That place I was looking at past papers on doesn't go back to 2012. Does this go back to 2012? That doesn't go back to 2012. I might have to just read your comment and go off of that. Because I think, I mean, in all likelihood, they will have changed the specification after 2012 at some point. Let me have a look. Ah, no, I have got one here. 2012, June 2012 question paper. That's the foundation one, not that one. Let's have a look. I don't think I can find it. Right, I'll go based off of what you've typed in the chat and try and use that. So you've put... I'll pin it so other people can see it. It says it's pinned, I can't see it now. Oh, there it is at the bottom. Right. So, let's scroll this down. Hopefully all this information is correct, otherwise the answer's going to be wrong. 5.7 grams. Oh, this isn't on the paper 2012. Right, on 1st of May 2012, the cost of 5.7 grams, so 5.7 grams of gold is 15960. Okay, I presume that is in rupees. Work out the cost in rupees of 4.6 grams of gold on the same day. So we need to get the 4.6 grams. So I'm going to not go straight there. I'm going to go down to 1 gram and then times up. So I'm going to go divide by 5.7 and then times by 4.6. Okay, that will give me 1 gram. So divide by 5.7 times my answer by 4.6. It's hot in this room. A lot of maths going on. 15960 divided by 5.7. 2,800 times by 4.6, 12,880. Oh, scroll down by accident. There you go. Okay, so that's how I'd approach a problem like that. Hopefully that's helpful. I'll unpin your comment now. Right. Let me see what else people put in there. Thank you very much for your time. You're very welcome. What time I've answered that. Answered all of those. Yeah, I think vectors is likely to come up. Yes, I've done a vectors question earlier. I did one of the typical ones that comes up, which I think is almost guaranteed to come up if vectors comes up, which I think is almost guaranteed as well, to be honest. I think there'll be some vectors on there. I think they're going to have that question, that style of question at the end of the paper, because it's not easy. So I'll scroll up and I'll show you it. But I did do this one. Okay. I can do another one if people want me to. I don't know how to do a poll, to be honest. Can I do a poll? I have no idea. No, I don't know how to do a poll. Right, can I do a poll? Engage with my audience. Right. Ask a question. Let's try this. Do you want me to do another vectors question? Let's go with that. This is cool. Right. No, non-linear, so I'm hoping quadratic. Yeah, I think there's a good chance quadratic simultaneous equations comes up. Will it be vectors on a line or shape, or this weird question and it has like a square root in it? I don't know how to explain. Will it be vectors on a line or shape? I think it will be like this one on the screen, something like that, if I had to guess. I mean, I don't know, is the honest. I don't know. You know, I'm a maths teacher. I don't get to see it in advance the same as anybody else. I have no idea until I speak to people afterwards and they tell me. I don't. How are you meant to differentiate the question on paper one? I haven't seen it, so I don't know. I just know that from the descriptions different people have told me there was differentiation in it. Indices questions on paper one. Let me have a look at my notes that I've got. There was some index laws, I believe. there could be, looking at this, some algebraic indices stuff. I did see a nice question on one of the papers earlier. How do you prove vectors are on the same line? Good question. So if they're on the same line, what that means is that one is a multiple of the other. Because if it's a multiple, then your A and B vectors are in the same proportions. And so basically it means it's going at the same angle, essentially. So if it's going at the same angle, it's on a straight line. So you need to show that one is a multiple of the other, i.e. you need to factorize it, show that inside the bracket is the other vector, and then outside is some number, and it could be a fraction, that's fine. You also need to state, you need to say the reason, as AB is a multiple of AC, and, this is the important bit, they've got a point in common, A, B, and C must lie on a straight line. Okay? Remember the first paper? Yeah, so some people found the first paper pretty easy, some people didn't. Yeah, I can do another vectors question. I don't know, to be honest. I'm going to do a little bit more and see what people, we'll see what will be helpful. Please don't spam, because I can't, I'm working through the comments and then I can't see everything. So I'm just going to delete those. I literally just got to your comment as you type that in. I don't know how much longer I'm going for. Okay. Maybe another 10 minutes, maybe a little bit longer. Maybe another half an hour, I don't know. But to be honest, what will probably happen is I will answer everyone's question in here, and then after that I'll get off, because there's not thousands and thousands of people in here, so the messages I will probably be able to get through and answer all of them, hopefully. But thank you for, you know, the respect. Similar shapes question, yeah, we can have a look at that. Was there a similar shapes question on the first one that I've got written down? Can I? Can't see anything at the moment. No, yes, we can have a look at a similar shapes question. Similar shapes. Hard similar shapes one. Right, and then if I have a look at this poll, hopefully I can see it. Right, yes. The polls, oh, there's 10 votes, right, so 10 people want me to, that's fine. Interquartile range, yeah, we can do that, that would be pretty straightforward. Right, let's just do an interquartile range question. Let me stop that poll now. So, let me just make a quick note of what I'm going to do. So, on here, we're doing interquartile range. We're going to do similar shapes. A difficult one, hopefully. I'll find one of those. Ratio ones, I'll have a look. The problem is with ratio, they are in so many different types of questions. It's quite difficult to... Quite often, to be honest, as well, they're earlier on. The elements of ratio that are in the harder questions are relatively straightforward. So I think, and they don't really utilise like ratio as much. So the understanding part of ratio normally comes in the earlier questions where it's maybe fractions, decimals, ratio, percentages, like a longer worded question as well. Right. What else? There was something else. It was vectors, obviously. Yeah, that's it, isn't it? I think vectors. Right. So let me have a quick look for some of these questions. Rolling the sleeves up a second. It's a bit hot in this room. This computer is pumping out some heat. Right. I did just see another vectors question. Let me just get that. Oh, perfect. There's a similar shapes one. Let's do this one quickly. It isn't a difficult similar shapes one, but it shouldn't take long to go through. Right, I'm going to try and do these a bit quickly. because why not? It's a bit more fun, but also I'm getting tired. So here's your similar shapes question. I'll move it a bit over here. Oh, I've moved it too much. Let's move that down. There we go. So shape form with two triangles. Got straight lines. Work out the length of D to E. So we're working out this length here. Give your answer correct to three significant figures. Now, this type of similar shapes question, you want to draw these two triangles or redraw them separately with the same orientation. So I'll draw the bigger one and then smaller one. And then we need to label them. So this is going to be A because I'm taking this triangle and turning it round that way. I'm going to take this triangle and I'm going to basically rotate it like this way. So DE is going to be on the bottom. So that's E, that's D. And the reason for that is these angles are going to be the same here. Okay. Oh, actually, wait a second. This isn't a similar shapes question. It looks very similar to one, but it isn't. The problem is, for this to be similar shapes, these need to be parallel, and they're not. Right, so I might skip over this one, but I'll just explain what you would do. So, work out the length of DE. We're working out this side here. What we're going to do is we're going to work out sine rule. So, that side, that angle, that side, that angle. So you work out this angle with the sine rule. You then do 180, subtract these two angles, gives you this angle, okay? This angle is then the same as this angle, and then you use 16, this angle, 19, cosine rule to get DE, okay? Right, I'll leave that one because it's sine rule, cosine rule. It looks very similar to a similar shapes one, which is quite ironic, the words of that, but it's not what I wanted it to be or hoped it would be. Right, where's this vectors question? It's not that. Alright, I've done that one. There was a similar shapes one on one of these as well. Here's a vectors question. Let's do this one. Right, next one. Okay, so let's have a quick read of this because this is a complicated type of question. The diagram shows triangle OAB with OA extended to E. Okay, OA is equal to A. Put that on the diagram. Okay. O to B is equal to B. So this whole thing here is B. Okay, and going that way. And O to A is going that way. M is the point on OB such that O to M to B is 4 to 1. So 5 parts of the ratio, so O to M is 4/5 of B, M to B is 1/5 of B. Let's write that on. So this is 4/5 of B. I wrote that really weird, let me do that again. 4/5 of B. And then this is 1/5 of B. Okay, so you know this is a question where ratio is coming in, but I think we're not using it loads here. And to be honest, if you're approaching this question, I would expect you to have a good understanding of ratio anyway, because it's a complicated question. This is, you know, like grade 9 kind of question. Really, Ice Cream Man is here. If you've watched my streams before, you know he comes all the time. Right, N is the point on AB, such that A to N and N to B are in the ratio 3 to 2. So this is 3/5 of the whole thing, and this is 2/5. So, in order to do that, I mean, it doesn't really matter which way around we want. I think let's go B to A, because I think in a moment I'm going to need to do M to N. So let's do it that way round. So B to A. So B to A is equal to minus B plus A. Okay, so this is 2/5 of minus B. I'm going to write it the other way around. A first is better. A minus B. Oh, sorry, scrolled it down. A minus B, and this is 3/5 of A minus B. Okay, that's going to be helpful in a second. Let's just make sure we're clear. That is going that way. Okay. Right. It then says O to A to E is in the ratio 5 to 3. So this is 5 parts of my ratio. This is 3 parts. So I need to divide that by 5 times it by 3. Okay, because if you think ratio, 5 boxes, 5 parts is A. So then we've got to work out 3 parts. Well, that's going to be 3/5 of A. Okay, you divide A by 5, get 1/5 of A, so that's 3/5 of A. Okay, so this bit here is 3/5 of A. Right, so find an expression for O to N in terms of A and B. That's part A. This should be the easier bit. So O to N. Now we're almost certainly going to use this though for part B, which is going to be the ratio bit. So O to N is going to be O to B plus B to N, which is O to B is just B. B to N is 2/5 of A minus B, which if I scroll down, B plus 2/5 of A minus 2/5 of B. So we get 2/5 of A, 1, because that's 1B, just don't write the 1, minus 2/5 is 3/5 of B. Okay, so that's the answer to part A. I forgot to copy over part B, so let me just get that. Part B, exactly like I thought, is use a vector method to show that actually, no, it's slightly different. It's to show that it's a straight line. So we'll have a look at that one. Straight line is how I explained earlier. It's slightly different though to the other question I did earlier on vectors. So MNE is a straight line. So we're going to do M to N and then M to E. Okay, and then one will be a multiple of the other. So M to N equals M to E equals. So M to N is 1/5 B. So 1/5 B. Add 2/5 A, or 2/5 A minus B. So that gives us 2/5 A. And then we've got 1/5 minus 2/5, so it'll be minus 1/5 B. Yeah, 1/5 minus 2/5 B. Okay, then M to E. I would always suggest with this one doing the longer one, the longest possible line. So M to E is the longest possible one, and then one of the shorter ones. So either M to N or N to E. Okay, so that's basically how you do it. You do the whole line and then do part of the line. If one is a multiple of the other, then they are on the same line. Okay, it basically means they're going at the same angle, and then you also need to state, like I said earlier, they've got a point in common, which for us will be M, because we've used M in both of these vectors. So M to E is going to be, you could do this different ways here. I'm probably going to do minus 4/5 B plus A plus 3/5 A. So minus 4/5 B plus A plus 3/5 A equals 1 add 3/5 is 8/5 A, and then minus 4/5 B. Now, what do I multiply each of these fractions by to get the ones above? 4. Okay, 2 times 4 is 8, 1 times 4 is 4. So M to E is equal to, I'm going to write here actually at the side 4 lots of 2/5 A minus 1/5 B. Okay, so then I can write M to E is 4 times by M to N. And then I would write my statement. I'm just going to type this bit, save my hand writing constantly. Let's make the text a little bit bigger so you can actually read it. I can't. how am I going to write this? As m to e is a multiple of mn, I would have the arrow above this if I was writing it, and they have a point in common, m, then m, n, e must lie on a straight line. Okay. Right. So that's that question. Next one. Let's cross off the vectors one. Interquartile range. I'll get one from Maths Genie because they are fairly standard if you've ever seen one on a paper. They're not something that usually is, or I don't think even can be, to be honest, particularly complicated.
Playing from home PC.
Thank you, Alexa. If you watch my videos, you'll know that happens all the time. Let me see if that is range. I don't want the range, I want the interquartile range. Right, I can't find a question, so I'm just going to steal these numbers from this range question, and I'm just going to use that to do the interquartile range. Okay, right. So typically what you will have is you'll get given some numbers like this, and you will get told to find the interquartile range. Okay, so to do that, I would count, obviously in my head, not out loud during an exam hall. 1, 2, 1, 2, 1, 2, 1, 2. This is actually quite a good example because here we end up with 2 numbers in the middle. So you want to go in between those numbers and split it up like that. If you do have a number in the middle, you circle it and then you ignore it. And what we're then going to do is use the lists either side, and we're going to do the median of each of these lists. Now, you can cross them out, okay? I underlined them first of all because I wanted to do, I basically wanted to be able to read them. So, I'm going to now cross them out at each end. 1, 2, 1, 2. Lower quartile is 4. 1, 2, 1, 2. Upper quartile is 11. So interquartile range is the upper quartile, subtract the lower quartile, which is 11, take away 4, which is 7. Okay, so that's the interquartile range. That's that done. Cross that off. Similar shapes. And then I might see if I can find a ratio question, like the type that I'm thinking of that is likely to come up. If I can't, I can't. Right, let's find a similar shapes one. I definitely saw one earlier. So, was it on this paper, this first paper? Let's have a look. Yes, there's one there. There's a nice indices one on this paper as well we might have a quick look at. I've seen this question before. If you haven't, this is a nice question to talk through, I think. It's a difficult similar shapes question. So here we go. A and B are 2 similar vases. The vases are such that the surface area of vase B is 25 over 64 times by the surface area of vase A. And that the volume of vase A minus the volume of vase B equals 541.8 centimeters cubed. Now, similar shapes, I would almost always write down length scale factor, and then we're going to do area scale factor. My brain is failing me at this point. Volume scale factor. Okay, those 3 things. Now this is talking about area. So this is going from surface area of B, so surface area of A to surface area of B times by 25 over 64. I am going to need to go actually fairly soon because I do need to eat dinner. I forgot I haven't eaten yet. Right. So that is our area scale factor, 25 over 64. Square root that to get your length scale factor. So that's going to be 5 over 8. And then to get from that to the volume one, which we need, you're going to cube it. So we're going to get 125 over, I can't remember 8 cubed off the top of my head, 512. Okay, so to get from volume A to volume B, we times by 125 over 512. Okay, so volume B. I'm just thinking about, basically I want to rewrite one of these and I want to make sure I get it the right way around here. So it would be in the same order this is. So volume B is 125 over 512 times by volume A. So now what I'm going to do is I'm going to replace the volume B here with this. So then I'm going to get volume A minus 125 over 512 times volume A equals 541.8. Okay, so this is 1 times volume A. So we do 1, take away 125 over 512, which gives me 387 over 512 times volume A equals 541.8. Divide both sides by that fraction and we'll get the volume of A. So 541.8 divided by answer is 716.8. So that's volume A. And then we go back to this bit here and we do volume B is 125 over 512 times by 716.8. Okay. So 175 centimeters cubed. Okay, right, that's that one done as well. Right, let me have a quick look at the chat again. Oh, what's just happened there? Complex ratio problems. I'm hoping functions will come out. Yes, me too. Functions. Circle theorems. Functions. I'm just going to get rid of all of this stuff in the chat that doesn't need to be there. Please don't be rude to people in the chat. You know, at the end of the day, I would think everyone's here to listen, and everyone's good at different things and not good at other things. And I get that people want me to do certain things, but you know, don't be rude. Just be polite to people. Right. Just 1 second. Does he teach more OS, something like that? I don't understand what that means. Right. Don't understand. So parallel lines. Sorry, 1 second. I'm just reading the chat here a second, people. Obviously it makes it more difficult because of all the other stuff in the chat to actually find the stuff that people want me to do. Paper 2H Jan 2021 question 19. I will have a look. No one's a moderator in this chat. But I can obviously remove people or mute people, etc. I keep scrolling up. Can I get a 2 with 15 marks? I don't know. I need to check the grade boundaries. Parallel lines. So parallel lines, I'll quickly talk you through it because I've done a lot of looking through the chat there. Parallel lines, there's things that you need to know which I'll put on flashcards tonight. And just use them tonight so you can use them again tomorrow morning. Co-interior angles, so they're the C shape. They add up to 180 degrees. Alternate angles, Z shape, they are equal. You've got the F shape, which is corresponding angles, they are equal as well. They're the main ones. There's also like an X shape, but that's not really parallel lines, that's just generally. Lines that cross at a point, opposite angles are equal. Vertically opposite angles are equal. Right, let me just... Right, I'm going to mute a few people in a moment if they're just spamming the chat with nonsense, which isn't helpful to anybody. Right. Okay, so I think looking at it, I've done a little bit of explanation about parallel lines there. There was something else in this chat, but in a moment, if people are continuing to just spam the chat with nonsense, I'll just remove them because I can't see anything that's actually useful and I want to help people. Okay, there was something else. Circle theorem proofs be likely to come up again. No, I don't think it would. I don't think a circle theorem's been on there. I don't think circle theorems, from looking at what I've got, from what I understand, I don't think circle theorems was on the first one. So I think that's something which could come up. And if I scroll up, what was on my predictions that I did? Did I put any circle theorems? Yeah, circle theorems is on here. So I'm expecting circle theorems to come up. How do you prove the parallel lines? You won't need to, is the first thing. So don't worry about proving them. So yeah, I'm not going to go into that now. Right. Can you do foundation tier? So some of the stuff that started this paper was on the foundation tier. So there's like a crossover section. So I would have a look at yesterday's stream. Recurring decimals will probably come up. I don't know. What did I have? I don't know if it did come up already. It might come up, yeah. Let me have a quick look at my notes. Yeah, recurring decimals I think could come up. I don't think that came up on paper 1. Yeah, I think circle theorems will come up. Pythagoras, essentially, if you're working out the hypotenuse, which is opposite the right angle, you square them both, you add them together, you square root. If you're working out the shorter side, then you square them both, you subtract and square root. Okay. Right, please do a difficult question on like volume surface area. Let's have a quick look. Yeah, I mean I've done. Oh, yeah, I'll have a look. I'll find one. There will be one. Here we go. Perfect. Let's have a look at this one. I think I'm going to do this one and then I'll probably call it a day. We'll see. But by the sounds of it, there's lots of people in the chat now because I can't read anything. Let's have a look at this one. Right, I'll put that over there. I'll let you have a quick read of that. I'm just going to check out how many people are actually watching. We've got 19, 18 people. Right. Okay, let's have a look at this. So, solid prism. This is towards the end of the paper. I think it was question 23. Prism is such that the cross section is a pentagon where AE is equal to BC. Okay, so that's X over here as well. AB is 2X. ED is equal to CD. Right, so this is symmetrical down here because that is equal to that. And that's helpful because of the angles. We know this is 120. I don't know if I need to do this, but I can. Now the total amount of degrees in a pentagon is 540. So 540 take away two 90s, take away two 120s, will give us that this is 120 at the top here, the total. Three 120s plus 180. Yeah, 60 to 70 marks for the first paper. You could get 7 to 8, yeah, because looking at last year's grade boundaries, it was 72 for a 8. So yes. But the grade boundaries obviously change each year. So May, you said Amar keeps messaging you. I don't. Right, I can't. I'll scroll up, but you know, if people are being rude in the chat, then like I said earlier, they'll get muted or removed, etc. Right, okay. What was I doing? I was doing this question. Let me do this question. Okie dokie. AED. Yeah, we've got that. Given that AG, where's AG? A to G is equal to B to H. Okay, so all of these are all 12. Calculate the angle that AJ makes with the base ABHG of the prism. So A to J. So this one up here. Okay, so I need to draw. What I would do with this question is draw the lines on here, like this. And then what I also want to do is I want to drop a perpendicular line to the ground. Okay, so straight down. And then I'm going to draw a line straight from where that hits the ground over to here. Okay, and then we need to work out, calculate the angle that AJ makes with the base. So we need to work out this angle. So this isn't actually a volume one, annoyingly, or surface area one. Right, to do this I need to work out this height, and then I also need to work out this length here. So let me just do that line again. So you can see we've got a triangle here. That's X. This is 12. Oh, this isn't going to be nice, is it? This is 8 here. I've got a lot of drawing on here now, which I don't love. Right, because it's an angle, it should be fine. So, it's a little bit awkward this because of all the stuff I put on the diagram so far. Let me try and clean this up a little bit. I didn't mean to do that. Let's undo. Right. So, I know what I'm going to do. I'm just trying to make it nice and neat for you to see what's going on here. So, first things first. I need to get this from A to, I don't know what, this base bit here. Let's do that. So I need to do x and 12 squared. So it's going to be x squared, add 12 squared, and square root. Okay, so that is going to be square root of 144 plus x squared. Right. It's not great. Let's see what else I can do in a second. Now this is going to be, that is x, and then I can use Pythagoras again to work that out. Again, I don't really love that because it's got x in it and I can't put that in my calculator. Is there any other information here that we can use? Right. One second. I'm just going to get rid of all of this because I'm wondering whether there's a way to work out the x which is going to make it nicer than using this. I don't love that. It doesn't say anything else in here, and we could do proportions. A to J. Right. I do need that triangle that I drew before. Um, don't love what I had before though. I don't love it. Right. I've got an idea. Let's do this height here. Now this bit, this angle's 30 degrees. Okay, because this whole thing here is 120, so that's a right angle, that's 90. So I'm going to use trigonometry, so opposite and hypotenuse. So that's going to be, if I'm working out the opposite, sine 30 times 8. I'm going to do this last one, then I am going to go, because my dinner's going to be ready, I think, soon. I haven't eaten yet, and if you haven't eaten, you need to eat. So that's 4. This height here is x, okay? Now, I then need to do this bit here. I need to do that straight line again that I had. So that is going to be, I had it before and I deleted it. So this is x here because that's 2x and this is 12. So 144 plus x squared and square root it, and then we've got 4 plus x, which again I'm not loving. Can I do something with this? I think I can to work out x, which would be a lot easier. Yeah, x squared plus 4 squared equals 8 squared. So x squared equals 16, sorry, plus 16 equals 64. I don't know how streamers do this all the time because it's so hard to concentrate with all the chat moving so quickly. So that's 48. So that gives me, the x is square root of 48. Which is 4 root 3. Right, that makes everything a lot easier because then I can actually do what I was doing before. So I've got x here and I've got 12. So we're going to do 4 root 3 squared plus 12 squared and square root it. Answer squared plus 12 squared, square root is 8 root 3. So this bit is 8 root 3. And then we've got 4 add x, so that'll be 4 plus 4 root 3. So then we need to do, we're looking at here, that's our angle. We've got opposite and adjacent. So opposite and adjacent is going to be tan. So we're going to do tan minus 1 of the opposite, which is 4 plus x, so that is 4 plus 4 root 3, over the adjacent, which is 8 root 3. Okay, and that should give us our answer. And I'm going to check this one because this is quite an interesting question, and it's one that I had to think about a little bit, and sometimes you do, you know. It doesn't matter how good you are, sometimes it takes a little bit of thought. And I've done a lot of past papers. So that gives me 38.3. Okay, to 1 decimal place. I'm going to check that one. I like that question. So that was not that one. That was question 23 on 2H, January 2H, I believe. So let me go back here. So January 2023, 2H. Let me have a look. I think it was question 23, I think. Yeah, 23. Yeah, 38.3. Right. Okay, so I'll have a quick look at the chat again. Give you some answers to your questions, then I am going to get off. I'll try and scroll back to where I last got up to. It's quite difficult. There was so much stuff. Good luck. Good luck. You need a 7. Good luck. Hope you get it. Edexcel out of 80, it may be. IGCSE Edexcel is out of 100.
I'm not quite sure how to help you with that.
Alexa, stop. Thank you. Right. Yeah, it's for IGCSE. Yeah, this live stream. Do you know that you got 50, 60 marks? Yeah, so all the people saying they got that many marks is just an estimate based on what they think they got right or didn't. What do you need to memorise before tomorrow? So if I have a quick scroll up to look at the important things or the things I think are likely to come up. Cumulative frequency, make sure you know how to do that. Plot it at the end points. Angles and polygons, make sure you know the formulas. So n minus 2 times 180 for the interior angles. That's the sum of the interior angles. Your exterior angles add up to 360. Functions, make sure you know your function transformations. I'm not sure, was there something... actually no, transformations of functions was on the first paper, I believe. Averages from a frequency table. Circle theorems, make sure you know them. Okay, make sure they're on flashcards or you know them. Constructions, maybe watch a video tonight about constructions. Corbett Maths is quite good, or Maths Genie. That'll just show you how to do them. That'll be about 2 marks if it's on there, so not a lot, but easy marks if you just watch a quick video. And graph transformations, make sure you, again, a quick video on that will help you. I've done a few of them though earlier. The main things to remember. Yeah, exactly. No need to overthink what's happened before, because you don't actually know what's happened, and we don't know what the grade boundaries are going to be. So just think about what you can for tomorrow. Predictions for grade 9 and for grade 8. I predict they're going to be similar to what they have in the past. What I would do, and I can't do now, is have a look at the last 5 years, do an average, or look for any trends. Have they been going up? For example, after COVID, the grade boundaries went up. I can never predict what they're going to do because basically they make that decision themselves. Nice one as well, sharing in the chat about the formulas that MathsPad has. That's very good. I'm not precious about sharing other people's content. Yeah, check that out. If you've got a link for that, Salma, put it in the chat. That'd be very helpful. Right, okay. I'll say thank you very much, and I'll leave it there. Before I go, actually, I'll just see if I can find that MathsPad. Maths formulas to remember for IGCSE. See if I can find it quickly. Mr. Astbury has produced a formula sheet. Everything you need to memorise for Edexcel IGCSE Maths, which looks good. Just remember, obviously, there's some things in there which are more likely to come up, some things which aren't. Let me put this in the chat, and then you've got it. Right, anyone that wants that, open that link now before I end the stream, because once I end the stream that will be gone because the chat isn't saved for some reason. So yeah, open that now. So you've got it open, and I'm going to say goodbye. So thank you very much for watching. It's been, I don't even know how many hours, 3 hours now. Hopefully it was useful. Hopefully you enjoyed it. Good luck tomorrow. Yeah, best of luck tomorrow. Hope it goes well. And if you're not doing your exam tomorrow, you're doing the like national GCSE or a different one. Good luck with that. And yeah, I will see you at some other point, hopefully, on the channel. Hopefully you enjoyed it, like I say, but also subscribe if you enjoyed it. I really appreciate that. It helps the channel. And please drop a like on this stream so other people can see it as well, or my channel just gets a bit more promoted, because yeah, I'd really appreciate that. You know, I put a lot of work into the channel, into streams like this, so yeah, I'd really appreciate it. Right, anyway, yeah, I'll stop blabbering on. Have a good evening. Good luck tomorrow. Yeah, bye-bye.